Evaluate the triple integral 1 by square root of 1 minus x square minus y square minus z square dx dy dz over the region bounded by the sphere x squared plus y squared plus z squared equal to 1. So, you have a sphere x squared plus y squared plus z squared equal to 1. So, I am going to solve this using the spherical coordinates. So, the spherical coordinates, making use of the spherical coordinates, transforming it into spherical coordinates, x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, z equal to r cos theta. We are going to make these are the spherical coordinates, and dx dy dz is r squared sin theta dr d theta d phi. How do you get this r squared sin theta? Why are you not writing dx dy dz equal to dr d theta d phi? No, I am not directly substituting. Dx dy dz is actually Jacobian j into dr d theta d phi. What is this Jacobian? This Jacobian is found out by using dou of x, y, z with respect to the partial derivative r, theta and phi. That is determinant dou x by dou r, 3 by 3 determinant dou y by dou r, dou z by dou r, dou x by dou theta, dou y by dou theta, dou z by dou theta, and with respect to phi, dou y by dou phi, dou z by dou phi. So, how to find dou x? Differentiate partially with respect to r. What is dou x by dou r? I will do it here. This is a separate process which I am supposed to show it. So, dou x by dou r is sin theta cos phi. Dou y by dou r sin theta sin phi. And dou z by dou r is 1 into cos theta. Coming to dou x by dou theta, differentiate partially with respect to theta. R into cos theta cos phi. R into cos theta cos phi. R into minus sin theta. Differentiation of cos theta is minus sin theta. And with respect to phi, R into sin theta into minus sin phi, r into sin theta into cos phi. Here dou z by dou phi, there is no phi present in the z, and therefore dou z by dou phi is 0. Now, finding out this determinant, sin theta cos phi into the determinant of r cos theta cos phi minus r sin theta, r sin theta sin cos phi 0 minus sin theta cos phi into determinant r cos theta cos phi minus r sin theta minus r sin theta cos sin phi 0 plus cos theta into third determinant r cos theta cos phi, r cos theta, you get r cos theta cos phi, r cos theta, it should be sin phi. dou y by dou theta, it should be sin phi. So, have I made any mistakes? Yes, here I should change it, sin phi, where else? Yeah, r into cos theta cos phi, r into cos theta sin phi, minus r sin theta sin phi, r sin theta cos phi. So, again I am going to solve this. Finding out the answer. Expanding this. Sin theta cos phi into, find out the determinant. This way it is 0, 0 minus or minus will become plus, plus r into r squared sin squared theta cos phi, minus sin theta cos phi, it should be minus sin theta sin phi, minus sin theta sin phi multiplied by r cos theta cos phi into 0, it is 0. These two negative will become positive, but already there is one negative sign, r squared sin squared theta sin phi plus cos theta into r squared cos theta cos phi sin theta cos squared phi minus, it will become plus r squared sin squared theta cos theta r squared cos theta sin theta cos squared phi, r squared sin theta cos theta into sin squared phi. Yeah. Now coming here, I will get sin theta cos phi r squared sin squared it will become sin cube cos squared theta. Yeah. Two negative sign positive, r squared sin squared phi into sin cube theta. Two negative sign will become positive, plus coming here cos theta separately outside, here also cos theta. So, I will have both cos theta, I will get r squared cos squared theta into sin theta into common cos squared phi plus sin squared phi. So, this will make it as 1. And what about these two? What is common? Sin cube theta is common. So, you get r squared sin cube theta into cos squared phi plus sin squared phi plus r squared into sin theta into cos squared theta. So, this will make it as 1, and finally you get the final result, r squared sin cube theta sin theta, which is common, sin theta common, sin squared theta plus cos squared theta. So, you are getting Jacobian j is equal to r squared into sin theta into, this will become 1, sin square plus cos squared is 1, and therefore that is why I have written this. Okay.